So we're looking at a few examples of piecewise functions, and the first one we have here has the function f of x, and then we actually have three different equations. And in a piecewise function, it's one function where it's going to have two or more equations. Now, it's still a function, so it still follows the rule of a function. So we can't just graph all three of these lines and think of it as like a system of equations. That's something completely different. But let's start with that idea, though. So let's just graph all three of these different equations, and then we'll talk about the intervals that are actually occurring. So I'm going to get my axes here. So the first one I have is x plus 3. X plus 3 is just your basic line. We'll make it this color. If it's x plus 3, it goes through 3 as a y-intercept and has a slope of positive 1. So there's our x plus 3. Then we have just 3, and 3 we'll do in this color. 3 is a horizontal line. It's essentially saying like f of x equals 3 or y equals 3. Goes through there. And last one is 2x minus 1. Let's go with, change colors here with my lines. Go with this color for that. 2x minus 1. There we go. So, we have our lines. Now as we look at them, oops, let me fix. This one's off a little bit. Should be going through that point. Okay, so we have our three lines. And again, if this was a system of equations, maybe it's an inequality, we shade, or we look at where there's points in common and notice how it forms a triangle. But we have these intervals here, and these are important because it's only where that function is represented. So if I look at x plus 3, that's occurring when x is less than or equal to 0. So really, if I went down and said, you know, I have sections going on here. One of them is when I have 0. Something on that side of it will be x plus 3. And between 0 and 2 is going to be 3, and everything greater than 2 is going to be 2x minus 1. So it's those portions of that equation that fits together. It's almost like I'm taking these three lines that I've graphed, and I'm kind of cutting out pieces of them, and I'm going to glue them all together and make a piecewise function. So it's pieces within the piecewise. So our first one again is x plus 3, and so what I'm going to do is I'm just going to get rid of any part of that that is greater than 0. So I'm just going to come through and erase from there. So yes, it does go to 0. It includes 0, and that's something we have to be careful with because it's less than or equal to 0. But it's everything else up until that point from the negative side. Okay, now we look at 3. Well, that only occurs between 0 and when it hits 2. So if I go to that point, it's between 0 and 2, and I'm going to erase on either side of it. If I was graphing the whole thing, yeah, it would be there, but I only want that piece of the function. Okay, and then the last one is when x is greater than 2. Well, any point where x is less than 2, I'm going to erase. So get rid of these pieces here. And what I'm left with is my function. And my function, we can see, isn't like our typical line. It comes up at a positive slope, it reaches a constant, levels out, and then it keeps increasing from there. And that is our piecewise function. This allows us to sometimes give a little bit different type of graph. In some situations, will need that. It's not always going to be one line for everything. So let's look at another one. I have x plus 5 when x is less than or equal to 3. I have negative 2 when x is between negative 3 and positive 1. And lastly, I have 5x minus 4 when x is greater than 1. So let's take a little bit different approach here. Let's just think of our intervals this time. So when x is less than or equal to negative 3. So something important happens on the left side of negative 3, or at negative 3 we should say, because it's x plus 5 on that side. And then between negative 3 and 1, something else happens. That's another interval. That's our negative 2. And then our last one, when x is greater than 1, is our 5x minus 4. So these are the clips of each graph that I'm going to put together to piece to make my piecewise function. Now, since I'm looking at individual intervals here, I'm not going to graph the whole thing and then sit there and erase it. Another approach we're can always do is plug in points. So let's say I'm looking at the x plus 5. Well, that's when x is less than or equal to negative 3. So that means it includes negative 3. So if at negative 3, the whole function, I'm going to use the x plus 5, I get 2. Pick another one. As long as it's less than or equal to negative 3, I'm fine. How about negative 4? I get 1. If I want to do negative 5, I'd get 0. So I get these points. And if I want to continue on, I'd see the pattern, which makes sense. It should be, if we look, we have a positive slope. It's going up 1 over 1 to the right. It's increasing, and it would probably hit at positive 5 when x was 0. But it's not, because that's not in the interval. Okay, now we have negative 2, and that occurs between negative 3 and 1. So that means any value I plug in, let's say negative 2, it's negative 2. If I plug in 0, it's negative 2. It'll always be negative 2 because it is a horizontal line over that interval. Okay, last one now, once it hits 1, this one includes 1 here, our last one, we have to look at the new equation, 5x minus 4. So I'll use 1. That gives me 5 minus 4 is 1. And if I do f of 2, I get 6. So let's plot these points here. I have 1, 1, and 2, 6. So if I was to just draw the line here, it goes off in that direction. Now you may be looking at it and say there's a gap, and what you don't want to do here is try to connect that together and think, oh, it just drops straight down. That's not what this functions are doing. In fact, if we look at that middle line, that horizontal line that we have, let's clean it up here, make it look a little better. It doesn't actually hit 1 because it's less than 1. So we want to indicate that there's a gap there and leave that open and then put a dot on the other one. So what it's saying is that function is going to approach 1. It's not going to hit 1. It's going to get very close. And then when it hits 1, right here, it drops down to the 0.11. And then we have the new function. So it has like a jump or a step in it. So there's our next piecewise function. Now what we can see in this one compared to the previous one is they're not always continuous. They may have a jump to them. I still have any value I can plug in for the function, so the domain is still all reals, but it's not going to be a solid line. We may have a step to it. Okay, last one we're going to look at here. Let's get some axes. So here I have, looking at the intervals, negative 1 is where something happens. There's a change there. So I'm going to write 2x plus 1 on the left side of it, and x squared minus 2 on the right side of it. So that's kind of that break point. If I would have had the two graphs and I cut them and pasted them together, the Frankenstein of functions, dare we say, it would be at that point. So 2x plus 1, I'm going to pick some points. So I know I can use negative 1, and that's going to be negative 2 plus 1 is negative 1. I could use negative 2, maybe. It'd be negative 4 plus 1 is negative 3. I could continue on plotting points. I think those are good enough. We have negative 1, negative 1, negative 2, negative 3. And there's our line there. Okay, now, x squared minus 2. That's not a line. We should know that. With that x squared, we should be thinking parabola. So it's not always as easy as just pick 2 points and draw the line, because a parabola isn't a straight line. But let's pick some points we can at least work with it. So I know 0 is in that interval. So plug in a 0, I get negative 2. I know 1 is in that interval. So let's see, 1 minus 2 is negative 1. If I do maybe 2, it'd be 4 minus 2, which is 2. And I see here that I get 0, negative 2, 1, negative 1, and 2, 2, which we can definitely see is not a line. But we're kind of curious, what happens, let's give me a line here. We see it makes sense, it's a parabola, it's going to keep increasing. But what happens between 0 and 1, or 0 and negative 1? Because that is in this interval. So we're going to kind of cheat a little bit. We use that idea of approaching. Let's say that function approaches negative 1 from the positive side. So I have my parabola, it hits at 0, negative 2, but then it keeps going and eventually gets to close to negative 1. Doesn't hit negative 1. So let's just say, well, what if that function approached negative 1? What would it be? So I plug in negative 1, I get 1 minus 2, which is negative 1, and it would reach that point, so it would connect. Now we ought to be careful. If we plug in negative 1 for our function, it still comes from the top one because that one includes negative 1. But that just considering the approaching idea will help us out. So now we have our next piecewise function. This one does connect for us.